and my team are here to present our project on implementation and analysis of wireless mesh networks using ESP8266. So we will walk you through how we did it, the theoretical portion of the project, our on-field testing that we did, what we learned from it, and what we learned. So this project was implemented using an open source library called Painless Mesh. It's a self-organizing and self-preparing ad hoc network that has accurate time synchronization. In this mesh network, all nodes are of equal priority, and it uses a star topology to establish the mesh. The messages are passed around using a JSON format so that the messages and the instructions can be combined into a single packet and sent out. So a bit more about the network layer. Every node acts as an access point for the other node to connect. And the other nodes can also connect to the access point of this node. So in this topology, time is synced periodically, and also when the connections are made or lost, so that every node is up at the same time. It has a precision of 10 microseconds, and messages can be sent around in broadcast mode or can be a single message addressed to a particular node. So the protocol explained a bit further. Each node on this mesh has an identifier using the last 4 bytes of the MAC address. It sends around data using a TCP-based connection, and time syncing is also done using this formula of offset given on the slide. So the adapter sends out a time at T0, the recipient receives it and sends it back at time T2. And using the formula, the offset is calculated, and it's repeated until the calculated offset comes around 10 microseconds. And this process is also repeated every 10 minutes so that everything is under synchronization all the time. So this library uses RSSI as the driving factor for choosing which node should be the main node and the subnodes. So inside the library, it takes the value of RSSI from the Arduino's DB for ESP8266 and chooses the node number. So in our project, we measured the same RSSI at varying distances and arrived at a model for our system and evaluated the performance. So now I will hand over to my teammate to present it further.
Hello everyone, my name is Sagar, and I would like to discuss more further in how we implemented it and what we used. So first of all, let's go deep into the partners function. We use partners function as the parameter to detect how the project analyzes. So it is varying on different factors like the distance between the transmitter and receiver, contour, the terrain, and all of these parameters are affected in the partners function. Also, we took the no wave signal, and also we calculated based on the LOS and free space. So Painless Mesh uses the proactive ad hoc on-demand distance vector routing protocol, which is continuous broadcast messages from sensor to the neighboring nodes. So Painless Mesh was used by proactive ad hoc protocol. And we implemented and deployed the ESP8266 in the urban environment, and using Google Maps, we calculated the distance based on and measured the RSSI value with real-time monitoring in one of the roads near our home. And we observed this full table based on the different calculations and distance. First of all, this RSSI value we calculated based on the different distances, and from the formula, part loss equal to transmit power minus RSSI. Part loss is calculated, and we got transmitted power and received and the sensitivity from the dataset of ESP8266. So we calculated RX power using the part loss model, which is also main 10 log 10 PT by PR value, and from that these all parameters we calculated one more parameter, that is radius, that how the probability of the connections of the nodes are there. So So based on the partial loss function, transmitted power and sensitivity, radius is calculated, and it shows that in the radius of 1.221 meter, all the nodes can be connected with this path loss, transmitted power and sensitivity. So all these parameters were used to analyze our mesh network. So I would then give to my colleague Ashish.
So basically what our on-field experience was that while this device that is here was working well in indoor environment, as soon as we started testing it in the outdoor environment, there were a lot of issues that started to come. So we initially started in an environment which was very densely trafficked on a main road, and then we saw that the range was even less than 50 meters, and sometimes it would not be even that. Then we moved to a less dense traffic environment, and then we saw that the ranges that we were getting from a point-to-point LOS connection was about 150 meters at the 14 dBm transmitter sensitivity, which is the maximum for this particular ESP. The other thing that we found was that this particular model can only be used for indoor applications, because the range at max is somewhere around 50 meters, where you would get a good connection or a reliable connection. So what we basically thought is that initially our assumption was that we can use it for forest fires or some other outdoor application, but due to the testing that we did, we also came to this conclusion that it can be mostly used for these applications. So indoor lighting automation is a non-mission critical application, which basically it is okay to lose some of your packets, because the next packet will reach and the light would turn on or turn off. And then the next one is indoor air quality measurement, because these devices are placed in a small environment. You can easily measure the air quality in a building. And then the last thing that we looked at was condition monitoring. So if it's a big shop floor of a factory, you might be able to use these ESP devices connected to your machines and then create a small mesh. The good thing about this Painless Mesh was that it is open source and it is low cost. So while the other alternatives were more expensive. So yeah, this was our main conclusion from this slide. So from this experiment. Thank you so much.
Very cool.
Open to questions. We are open to questions. Yes. Yeah.
We had the clear one of the but our partner is limited by the angle of PTVC, so based on that. So we consider the free space and the LOS. Consider this control model. Yeah.
Good job, guys.
Thank you.